This video will cover the anatomy of the human heart. Hello everyone, this is Shireen Hafiz. Make sure to watch my other video about the blood supply to and from the heart. It covers coronary arteries, coronary dominance, and cardiac veins. This video will focus on the anatomy of the heart, not the blood supply to and from the heart. So let's get started by looking at that human heart or plastic heart, and let's define the four chambers that you all know and love. So this is your right atrium, and this is your left atrium, and this is your right ventricle, and this is your left ventricle. So if I think of how the heart is positioned in the thoracic cavity, so the right border of the heart is formed by the right atrium, and the left border of the heart is formed by the left ventricle and a bit of the left atrium, and the inferior border of the heart is mostly formed by the right ventricle with some contribution of the left ventricle. And observe that the apex of the heart is on the left ventricle, and this is the base of the heart up here. Okay, let's define first and see some of the grooves, the sulci that's on the surface of the heart that will be important in our discussion. So this is your coronary groove. It goes all the way around. This is all coronary grooves. The coronary groove separate your atria from your ventricles, and then you have two interventricular grooves, one on the anterior surface and another one on the posterior surface. So this is your anterior interventricular groove, and on the posterior side this is your posterior interventricular groove. And obviously these grooves separate your right ventricle from your left ventricle, and they demarcate the interventricular septum, which is the septum inside between your right ventricle and your left ventricle. Okay, yeah, let's keep going, and let's define these major vessels that I see coming at the base of the heart. So let's start with this one. This is your superior vena cava, and those are tributaries of the superior vena cava. This is your right brachiocephalic vein, and this is your left brachiocephalic vein. So both form that superior vena cava. And then here is your aorta. This is specifically the aortic arch, and these are the three branches that arise from the aortic arch. This is your brachiocephalic trunk. The brachiocephalic trunk further divides into your right subclavian and right common carotid artery. Then here is your left common carotid artery that arises directly of the aortic arch, and then here is your left subclavian that arises directly of that aortic arch. Okay, so we had that superior vena cava, we had the aortic arch, and this third one is your pulmonary trunk. Okay, now let's see what we can see inside those chambers. So I will open that, and I will look at the inside of your right atrium. So what opens into the right atrium? Of course, you have your superior vena cava, okay, and your inferior vena cava, and also your coronary sinus. Remember, coronary sinus, that's the site for venous drainage from the heart. Basically low oxygenated blood from the heart itself collects into that coronary sinus, and the coronary sinus opens into that right atrium. Then I see a fossa here that's called fossa ovalis. So fossa ovalis is the remnant of foramen ovale. That's the foramen that was present during fetal life that was allowing blood to go from the right atrium into the left atrium directly, which of course we do not want that to happen after birth. So that foramen already of course is closed, and it's released by this fossa ovalis. Okay, then I have this big opening in here between the right atrium and the right ventricle. This is your right atrioventricular orifice. That right atrioventricular orifice is guarded by the right atrioventricular valve or the tricuspid valve. It is called the tricuspid because it has three cusps, this and this and this, which are not great by any mean here on that plastic heart, but you get the point. We have three cusps in here for that tricuspid valve. Then the cusps connected to these tendinous cords, those are chordae tendineae, and the chordae tendineae further connects with these muscles in the wall of the ventricle. Those are papillary muscles. Okay, now we're done with the contents of the right atrium, but I would like you to think of the parts of the right atrium. So if I put this back, if you think of the right atrium, it has two parts. One part is that one big space where all these veins drains. That part is your sinus venerum. That's the smooth part of the right atrium, sinus venerum. And then the other part is this part that looks like an ear. That's your right auricle. So I think, well, you too need to think of the atrium as having two parts, the sinus venerum and the right auricle. The sinus venerum has a smooth wall, but look at the auricle. The inside of the auricle has these ridges. Those are called pectinate muscles. And I would really pay attention to the word pectinate and do not confuse it with papillary, the one that's in the ventricle. I've seen throughout the years the students confuse those. The only difference, that the only really common thing that they both start with a P, but they're completely different things. So anyway, back to pectinate muscles. That's in the wall of the auricle. The pectinate muscles and the smooth part of the atrium have a border between them. That border is this crest in here. That's your cresta terminalis. And that actually structure is important because at that superior part of that cresta terminalis, that's where your SA node, sinoatrial node, is present. Anyway, cresta terminalis. On the outside of that cresta terminalis, there is a groove that's absolutely not showing on this plastic heart, but you get the point. If you go to the anatomy laboratory, you will see it. It's called the sulcus terminalis. So cresta terminalis is on the inside and opposed on the outside by sulcus terminalis. Okay, I will put this back. So we're done with the right atrium. Okay, now we're going to get our attention to the right ventricle. So what's inside the right ventricle? We've already talked about the structure of the right atrioventricular valve or the tricuspid valve. One more structure that's not really showing here, it's called moderator band or trabecula septomarginalis. Basically, as the name implies, trabeculum, that's the trabeculum, that's a band, and septo, that means it starts at the septum, which is the interventricular septum in this case. Marginalis, that refers to the wall. So it's a band that crosses here between the interventricular septum and the wall of the ventricle. Trabecula septomarginalis or moderator band is part of the conduction system of the heart. One more thing that's actually showing here. So if you look at the wall of the ventricle itself, do you see these irregularities or ridges in the wall of the ventricle? This is called trabeculae carneae, and that helps in with ventricular contraction. So trabeculae carneae. Okay, back. This is your right ventricle. The outflow tract of the right ventricle is your pulmonary trunk. This part of the right ventricle that looks like a cone that leads to the pulmonary trunk, this part is called the conus arteriosus. It's like the cone of the artery. So conus arteriosus. Okay, now get your attention to the pulmonary trunk itself. So there is a valve between the right ventricle and the pulmonary trunk. This is your pulmonary valve, and the pulmonary valve is a semi-lunar valve, which basically means it has these semi-lunar cusps, which they are called semi-lunar because they look like half moons. Okay, so right ventricle done. We're done with the right atrium. We're done with the right ventricle. Let's now think of the left atrium. So the left atrium, what's drains in it is your pulmonary veins, and there are right pulmonary veins appear, and there is left pulmonary. Oh, I actually switched them. Here is your left pulmonary veins, and those are right pulmonary veins. So in each there is a superior one and inferior one. So basically we have two superior pulmonary veins and two inferior pulmonary veins, so with a total of 4 pulmonary veins that drain into the left atrium. Okay, I hope you infer here that your pulmonary trunk divides into a right and left pulmonary arteries, which of course they go to the right and left lung. Your pulmonary veins, they carry oxygenated, high oxygenated blood, but your pulmonary arteries carry low oxygenated blood. That's why they're colored here, like that's blue and this one is colored red. Okay, so left excuse me, left atrium, and if we look on the inside, you can see here are really the opening of the pulmonary veins on the inside. Okay, great. So we're done now with the right atrium, we're done with the right ventricle, we're done with the left atrium. Now we get your attention to the left ventricle. So the inside of the left ventricle really looks very similar to the right one, with some exception. One, look at the thickness of the wall in here. The thickness of the wall, of course, the left ventricle is much thicker than the right one because the left one pumps blood into a longer distance. Two, we have a valve here between the left atrium and the left ventricle. This is your left atrioventricular valve. That left atrioventricular valve really demarcates the left atrioventricular orifice between the left atrium and the left ventricle. That valve, the left atrioventricular valve, also has another name, a very common one, probably you all know it, the mitral valve or the bicuspid valve. So that valve, it has 2 cusps, that's why it's bicuspid. So these are the cusps of the valve. Again, not great on this heart, but the cusps connect to this chordae tendineae, and chordae tendineae again connect with papillary muscles. So very, very similar structure to the right one, with the exception that this is 2 cusps, this is 3 cusps on the right side, it's 2 cusps on the left side. Still, the wall of the ventricle has trabeculae carneae. Again, I can show you here. Again, here is, let me put this one away. So here is again trabeculae carneae. Those are the irregularities in the wall of the ventricle. Okay, great. So we did say that the outflow tract of the right ventricle was your pulmonary trunk. The outflow tract of the left ventricle is your aorta. And yes, there is a valve between the left ventricle and your aorta, simply named the aortic valve. The aortic valve is also a semi-lunar valve, just like the pulmonary valve. Both of them are semi-lunar valves. But the difference is the aortic valve is more complicated. In which way exactly? So the semi-lunar cusp aortic valve enclose like spaces or pockets in them. They are called aortic sinuses. We have a right aortic sinus, we have a left aortic sinus, and we have posterior aortic sinus. So the right one and left one, they are named so because your right coronary artery arises from your right aortic sinus, and your left coronary artery arises from your left aortic sinus, and then the posterior one actually is called the non-coronary because nothing arises from there. So aortic sinuses, those are again the spaces that enclose within those pockets or cusps of the semilunar valve of the aorta. Okay, so done with this. One more thing that I see here. Here is your pulmonary trunk. Okay, here is your aorta, and these are really the two branches of the pulmonary trunk. Here is your left pulmonary artery. This is your right pulmonary artery. Between your left pulmonary artery and your aortic arch, this is your ligamentum arteriosum. So ligamentum arteriosum is the remnant of ductus arteriosus. Again, that was a structure that's present during fetal life that was pumping blood from the pulmonary trunk into the aorta. Now we don't need it, so it's now ligamentum arteriosum. Okay, great. Now I want you to think about the journey of a drop of blood that's anywhere of the body. Let's just pick any drop of blood that's at your lower half of the body. Let's say anywhere below the level of the diaphragm. So anywhere below the level of diaphragm, the blood will be collected with that inferior vena cava. And anywhere above the level of diaphragm, it's going to be collected by your superior vena cava. And of course, the blood from the heart itself will be collected through that coronary sinus or some other little veins, anterior cardiac veins. Anyway, everything, anywhere in your body will drain blood into that your right atrium. So the blood will go from the right atrium through your right atrioventricular orifice into your right ventricle, and then from your right ventricle through that pulmonary valve into your pulmonary trunk, and then the pulmonary trunk divides into right and left pulmonary arteries. They will go to the respective lung. The right one, of course, will go to the right lung. The left one will go to the left lung. What will happen in the lung? The blood will be oxygenated, and then that high oxygenated blood will be collected to come back to the heart by those pulmonary veins. So the pulmonary veins will carry this high oxygenated blood into your left atrium, and then from the left atrium into your left ventricle. So what's the outflow tract of the left ventricle is your aorta. So through that left ventricle, through that aortic valve into your aorta, and of course from the aorta will distribute to everywhere in the body. I believe that is it. Thank you. See you in the next video.